Okay, hi, how are you? And welcome to the week number three tutorial questions. Uh, well, you know that week number three mainly is going to be about the relative acceleration equation and its application. We're going to start with a simple example like the one we have right now. It's a stick that have two wheels on both ends. It's going to be laying on the wall. So definitely we're going to have the tire will be slipped and that this will take the whole road to go to the well, let me sketch on that. Okay, so due to the weight of the road, this will go downward, and this will push this wheel to go to the right. Well, this wheel, of course, is going to go downward, and you can see that the acceleration we're going to have for the wheel A is going to be 5 meters per second square, while the velocity is going to be at 6 meters per second. It's required to find the angular acceleration of the road, and definitely this will be in that direction. Okay, that's the omega required, and also the acceleration A at the point B. Okay, so we need to find these two parameters. As you can see that at that instant, the length of the link is of the road, sorry, is 5 meter. The height is 4 meter. By making a simple calculation, we'll find that this length is going to be about 3 meters. Uh, Sketch the line perpendicular to the first velocity. That will be the line AIC, and we have another line perpendicular to the velocity at B. This will be the BIC, and this will be the instantaneous center that we're going to use later. Now, if I would like to know what is the omega here, I will start by using this velocity. Okay, I can know what the length of that link. The omega of that link is going to be the same as the omega of the bar because as we mentioned earlier, that the whole thing, the whole triangle we're going to have here is going to be considered as a solid plate, and thus the omega at each point is going to be the same, but the velocities are going to be different. So we shall go with the solution step. First, we need to find the angular velocity of the road at this instant. So definitely the omega is going to be around the z-axis. That means it's going to have a k value for the solution. And we can start to find the solution by uh, first having the IC do the basic calculation. And we said that the link AIC or the R AIC here is going to be equal to 3 meters. And this will help me a lot because I know that the velocity here is 5 meter per second, sorry, 6 meter per second. That's perpendicular to that link, so I can find the omega of this link. So we are going to start by writing down the equation, locating the instant center of the road AB, and we can determine the omega. The omega is equal to the velocity at the point A divided by the length between the point A and the point IC, which is going to be equal to 3. And the velocity is 6. That means that the omega is going to be equal to 2 radian per second. And obviously, you can see that this direction is going to be to the counterclockwise, or you call it anti-clockwise, but the CCW is referred to the counterclockwise direction. Now, that's it. We found the omega. That's very easy. And if I would like to find the velocity at the point AB, I can find this one very easy because the velocity in that case is going to be equal to the RBIC multiplied by 4, which is going to be 8 meters per second. But I don't need the velocity now. I need the acceleration. So in that case, we need to apply the equations for the accelerations and find then the relative angular velocity equation. But it's going to be nice actually to write down here that the VB is going to be equal to the length of that link, which is equal to 4, multiplied by that omega, which is equal to 2. So it's going to be equal to 2 times 4, and this will be 8 meters per second going to the right. Let's make it positive. This one is negative, of course. So if I'm going to represent the accelerations of the point A and the point B together, the point A obviously is going to be minus 5 meters per second. It's minus because it's going downward. Okay, so that's minus 5 meters per second square. We put the J because it's along the y-axis. Now for the point A is going to the x-axis to the right, okay, and that's make it positive. So it's going to be written as the ABI meter per second square along the x-axis and plus for the right. So applying the relative velocity equation, well, we described that in the lecture. So we're going to have that the velocity, the acceleration at B is going to be equal to the acceleration at A plus the alpha of the length AB, which is the angular acceleration of the length AB, cross product by the length BA, and negative, now minus omega square multiplied by the RB slash A. Here we are going to use this one as a scalar. That's mean it's not going to be K square, because even we're going to have this K square is going to be equal to K times K is going to be equal to 1. So we don't have to worry about that. We can use it as scalar, while this one is going to be it's going to be used as a vector. So now we are going to substitute whatever we have. The AB is ABI. The AA is minus 5J. The alpha AB is going to be the alpha ABK multiplied by the RBA. If I'm going to write down the length RBA, the road itself, as a vector, is going to be 3 to the x direction. So 3 positive minus 4 for the j. So 3I minus 4j. And the same thing is going to be repeated here. The omega is already 2, so we can have this one is 4. So I'm going to substitute everything in it, as I mentioned earlier, and we can solve for that, and we can find the value for the A, B. So that's minus 5j. The k times the I is going to be equal to j. The k times the j is minus I. And the same thing, well, here we're not going to have, it's just a scalar value. So we're going to have minus 12i plus 16j. Okay, so we're going to solve for the equation. We know that on the left side, the ABJ is 0. So I'm going to leave it at 0. Solve for that side. Okay, now you can see that we have the i's and the j's. And I can solve for the alpha AB first by using the j's on the left, and the j on the right is 0. And I can solve now for that. So I can say that the AB I is equal to the 4 alpha ABI minus 12I. Okay, and that's what we have for this equation. Now for the j, here we have the j0 on the right side, on the left side, and here we are going to have minus 5. We have plus 16. Minus 5, yeah, plus 16j, and this will make it 11. And we have 3 alpha AB. So we're going to have that equation, and this will help me to find the value for the alpha AB. And then I'm going to substitute in the first equation to get the value for the acceleration B. So we solve for the both, and we're going to get that the AB is going to be equal to negative 26.7 meter per second square, going to the left because we're going to have a negative value. And for the alpha is going to be negative 3.67 radian per second square to the counterclockwise, the same direction of the omega. Okay, and because it's negative as well. In all the cases, that started from solving the first equation, the second equation here. The alpha is going to be equal to minus 11 divided by 3. And this will give me 3.67. And then I'm going to substitute this alpha here. So it's going to be 4 times 3.67 negative minus 12, and this will give me negative 26.7 meter per second square. Okay, once again, I would like you to watch this one. If you have any question, we can answer that during the tutorial session.